What we're looking at today is very simply, what is the purpose of the operating system? Why do we need one? And what really is it? Why do we need the operating system? Now, anything that happens inside a computer, whether it's displaying something on the screen, saving a file onto the hard drive, is really all down to the very clever manipulation of bits and binary. So if I wanted, for example, to display a turtle on the screen, what I would do is the turtles can be made out of pixels. Those pixels are made out of binary. That binary would then be sent down buses to the graphics card and stored in the graphics card memory. It would then be sent to the monitor and displayed. So everything that we need to do through interaction with the hardware is going to be done via manipulation of bits. So without the operating system, that manual manipulation of bits would have to be done by the programmer. And that is a very, very complicated thing to do. So saving things onto the hard drive, if I had to do that manually, it will require a hell of a lot of code. So it is the operating system that does all that kind of device management, that memory management, that software management, the scheduling of applications. So we don't have to. So on the screen at the moment, I've got a tiny little section of the Linux kernel. Now, when we say the word kernel, what we're talking about is the core parts of an operating system. So this is the stuff that's managing the devices, this is the stuff that's managing memory and all the kind of core things that the operating system has to do. So the code at the moment, you do not need to understand what this code is doing because it's very advanced, but this is part of, and I do mean part of, the code to actually start to set up or mount drives such as the hard drive. The Linux kernel at the moment is over 18 million lines of code. Now, if you had to write that code for every time you want to do hello world, it would just be bonkers. It would be a nightmare. So there's the need for that operating system. We need it to manage all these devices, to do the basic things so we don't have to write that code when we're programming. Now, if you are interested, it is possible to bypass the operating system and kind of write code yourself. On the screen at the moment, I've got some assembly code, and this is written in x86 assembly, which will display Hello World without an operating system. So actually, instead of loading up Windows or Linux or whatever it happens to be, it will just simply display Hello World. It will use BIOS to help it. So even though it's not using the operating system, it's still using the basic input and output system, so using the ability to display text using BIOS. So even then, it's still relying on other code, but fundamentally, it will display Hello World without an operating system. Now, as you can see, this is not simple code. Okay, again, I'm not expecting you to understand it. That's not important. What is important is the realization that the need for the operating system is really clear. Okay, having to code like this on a regular basis would be incredibly difficult to do. If you are interested and would like to have a go at coding without an operating system, I've included a link where I got this code from, and it just basically teaches you how to do some basic stuff without the operating system. It's not for the faint of heart. As you can see, it's incredibly complicated code. It doesn't necessarily explain it very well, but if you're interested, please do have a look at it. So what does the operating system actually do? So we know why we need it, because we don't want to have to write all that really complex code. But what does it really do? So it schedules processes. Okay, so what we mean by that is it will decide which processes run in which order. If you think back to when we were looking at multi-cores and parallel processing, we looked at the idea that different processes would run on different cores, and then those would be swapped over in order to give the illusion that they're all running at the same time. It's the scheduler that decides that. Some operating systems, for example, like the iOS, don't do multitasking in strictly the same way as we expect. So really we can sum it up as saying it's a platform to run software. So it allows all the things that need to happen in order to run your apps and programs. Memory management is really important. This is what's going to partition memory and allocate that memory to different processes. And we've got two ways to do it, which we're going to be looking at later, which is paging and segmentation. But On its most basic level, it is about making sure that each process has memory it can use when running programs. Storing files onto storage devices, such as the hard drive. We have something called a file system. Now, a file system is how we're going to save a file onto a drive. So there are lots of different types. So FAT, NTFS, ext4, and the operating system is going to manage that for us as well. So device drivers, managing devices in general. So the operating system will allow device drivers to be loaded, to be used, and also linked into that is the use of interrupts. And we're going to look at what interrupts are, but essentially on the most primitive level, when a device needs something to happen, it sends a signal to the CPU to say, hang on a second, this needs to happen, and then the CPU informs the operating system. The operating system will then run a device driver to manage that interrupts. So the operating system has to manage devices. It provides a user interface. Now, we're quite lucky nowadays that most of our operating systems are all graphical user interfaces. We've got windows, menus, icons, pointers, and all that sort of stuff. Or we might have an operating system which is just command line. We have to type our commands out. For utilities, now utility is just a really simple program which helps us get the job done, as it were. And there's a lot of utilities, little extra software that comes installed with your operating system. So, for example, clocks, notepads, antivirus software, firewalls, those kind of little bits of software which come with our operating system to help us. Security, it's really important that the operating system provides security for us, and we're going to kind of cover that in a bit more detail in a moment. Kind of delve into the detail a little bit more. So scheduling is going to be in a future lesson. So I'm just going to kind of again summarize. A process running is a running program. So when we open up a program, I double click on it and it starts to load up and it starts running. The second it starts running, we call that a process rather than a program to make a distinction between the two. And operating systems, or most operating systems nowadays, will allow multiple processes to run at the same time, especially if we've got a multi-core environments. So scheduling allocates process cores, it decides the order of processes, and it basically enables us to do multitasking. For operating systems that's not multitasking, it still provides a platform to run those programs. Memory management, as there are lots of processes running, they all going to require memory in some way. So it might be that it's the Word document working on at the moment that hasn't been saved yet. It might be variables in your game. There's loads of reasons why you might need extra data. So it stores the program in RAM, and also store the data and variables of the program. So we've got two things that get stored. If you remember back to the von Neumann architecture, in RAM we'll have both instructions and data, so the program itself and the data that program uses. So the memory manager needs to partition that memory up in a sensible way, it needs to allocate that memory to processes as and when they need it. It also might need to enable virtual memory, which we'll look at in another topic. But fundamentally, if we start to run low on RAM, we might decide to use the hard drive as extra memory. So that's going to be virtual memory. File management. So saving, loading data is from different devices is a core part of the operating system. So when I save a file to a device, we need a way of structuring that data in a way that it can be read and used again. So we call that a file structure, and different operating systems have their own one. So it does need to be managed by the operating system. So Windows, for example, uses NTFS. Mac uses HFS. And Linux uses ext4. This is not a big part of the course. There's not going to be a separate topic on file management. You don't need to know how file management works. Just have a very broad understanding of that as part of the operating system. So device drivers, because devices are made by different manufacturers, they all work slightly differently. Even though I might have two hard drives, they're both 1 GB hard drives. It's a bit small nowadays, but there you go. Both 1 GB hard drives, but made by different manufacturers. It could be that they work slightly differently. Now that little bit of difference needs to be accounted for. So when the operating system wants to save a file, it doesn't need to worry. It doesn't want to worry about whether that device is a Westgate or whatever other manufacturer you can think of. It just wants to save the file. So device drivers essentially enable us to translate what the operating system wants to do into something the device understands. So we're going to cover that in a bit more detail in a future lesson. Interrupts, when a device requires attention from the operating system, it sends an interrupt. So the operating system is responsible for managing that interrupt and ensuring it's dealt with, okay, in some way. This is done by selecting running a correct interrupt service routine, and again we're going to be covering this in detail later. So you can think of an interrupt service routine as a little bit of software which is designed to deal with an interrupt. So the operating system's job is to ensure that when an interrupt occurs, it selects and runs the correct ISR. And also user interfaces. Now on the screen at the moment I've got 3 user interfaces. The top one is going to be a Mac. The next one is Windows 10. And the bottom one is Linux, specifically the Cinnamon user interface. Now, different operating systems have different user interfaces. They do look a bit similar at times. You know, there's a lot of commonality between them. They've all got Windows in these 3 cases, but they do work differently. So the operating system will provide that user interface. Okay, it's basically enabling the shell of it. So, for example, on here you can see there's a window. So I'm just going to kind of draw a box around the window. So the operating system is handling out the window, but what's inside the window here is being managed by the application itself. Okay, so that's a File Explorer utility, and it's the File Explorer utility is kind of managing what should display in that middle, but the operating system is providing the mechanisms to display window, also all the other little bits and bobs, so how to display menus, how to do little buttons, all those kind of interactions. They're part of the operating system code, but the application is free to use them as it sees fit. We call Windows icons, menus, pointers WIMP as kind of a clever acronym. So yeah, it's the operating system that's managing that user. Utilities, now these come bundled with most operating systems. They're tiny programs which you do use on a regular basis, but you don't really normally think about them. So antivirus, File Explorer. So when you are going to my computer and trying to find your files, that's called File Explorer. Defragmenter if you're unlucky enough to use Windows. File compression, and there's loads of other examples. So these come with the OS to support your day-to-day computer needs, and we're going to be looking at utilities in a bit more detail on another topic. Security is really fundamentally important. I think security now is becoming more important than it ever has been in the past. So the operating system provides security to protect your files. So for example, it might be that certain files we want to protect from general day-to-day messing around. So it might be linked to admin. We might have multiple users using the same computer, so each other's files are protected from one another through passwords. We want to protect memory from other processes. We don't want processes to be able to access each other's memory for security reasons. Unauthorized people accessing the computer, so we want to have some way of maybe logging on through biometrics or a password or a key or whatever happens to be. And restricting what the user can do on the computer. So can that user install software? Can that user, be able to access the C drive? Being able to fine tune the access rights of a user. And that security element is really important because especially when we start to moving into a network environment, we want to make sure that users have the right security privileges, otherwise things might go wrong. So time for a bit of a pause on the task. So make a list of all the core features of the operating system and explain each of those purposes. Okay, so it's really important that you have that kind of overview what the operating system does. Okay, it's quite a classic question to ask, what does the operating system do? And you need to be able to reel off all those ideas. Then pick 2 operating systems, so it could be 2 that you're familiar with, and I suggest it is. It could be mobile ones, so iOS and Android, and do a bit of research around it and create a little presentation to write how they differ by user interface. So how the user interface works. I mean, a nice interesting one might be to do a mobile user interface compared to Windows maybe, showing how they differ. Security, how the security differ. Utilities, what utilities do they come bundled with, and how do they differ, and how is file management done? So is that through, I know, Windows, it's NTFS, and maybe what some of the differences. So this is an opportunity for you to maybe delve a little bit more into depth on what the operating system does. So I don't just simply regurgitate the basics, actually do a little bit of backwards reading on it. Operating systems is a massive topic and there's loads of information out there on it, so do take this opportunity to actually start to really get a nice solid base so all the next part of the course will fit in. I will say that when we start looking at scheduling and memory management, they are quite abstract ideas and concepts, so the more reading you do now, the easier that section will probably become. So, subject clarification, you need to have an understanding of why the operating system is required. So that's kind of the first few slides when I was showing you just the complexity of having to write code without an operating system, and just how much operating systems can help in doing the basic day-to-day management of the computer. So along with the different tasks it can perform, and here is an example list. So these are most of the ones that I've covered. So these are the ones that you are should focus on. There are other things the operating system does, and you can, if you want to, maybe do a bit of wider research to look into some of those ideas.